Cool guys, so welcome to the 41st IoT meetup. Really amazing having you guys. Braved fierce Scottish weather to be here. You should be very proud. But yeah, enough about me. Tonight's all about you guys, so we'll go straight into announcements. And if there's any public service announcements or anyone who wants to address the community, now is your time.
Hello everyone and welcome. I'm Leo and I recently started a startup called Oximeter. We do machine learning services, so if you're interested or would like to talk about machine learning, feel free to talk to me. We're also online, oximeter.com. So yeah, that's it. Enjoy.
Amazing. Thanks, Leo. Who else?
Hi, I'm Al. I've just started a sort of LoRaWAN and the Things Network meetup, and the first one is going to be on the 27th of March, so in a couple of weeks' time. So if anybody's interested, our first speakers are going to be Simon and probably Mark from the University of Edinburgh, talking about their LoRa network and things they're doing, and we're going to be meeting there at Argyle House that way. So you know where you are already. So yeah, if you're interested, it's 27th of March. Cheers.
Anybody else? Okay, I think our most important member of the community for today, given that we've just finished the pizza, Trish is our sponsor of this event. So over to you, Trish from Eagle Lab.
Hi there. Firstly, it was firstly just saying, as always, I mean, delighted to be partnering with IoT Scotland Meetup. The reason we do that is Barclays, we don't have all the answers at all, so we try and collaborate with really smart people like yourselves to actually educate and inspire others. So myself and Dan's here from Barclays. Where are you, Dan? What we do is we're listening to the talks, listening to yourselves, and we learn from you, and then we can go on and talk to customers and other people in our networks and try and let them, learn about IoT and be more aware of it. And that's one. So the other thing that we've got that's going on just now that I thought I would bring for you is we partnered with MMC Ventures and we've done a big report on AI. So I know that's an IoT meetup, but I just obviously think if anybody wants a copy of it, so there's a book, the AI Playbook, the step-by-step guide to taking advantage of AI in your business. So if you're interested in that as well as IoT, there's a book, and then there's the State of AI Divergence 2019, the annual report. This was just launched last week in London. I've got copies in the lab if anybody wants them, and I've also got online copies if you're quite happy to just read it online. Okay, just see me afterwards. All right, thank you very much. Thank you.
Thanks so much, Trish. I think, yeah, with the amount of sensor data that the IoT devices pick up, I think the convergence of AI and IoT is spot on. So, yeah, with that, I think let's head on straight over to our speakers. Our first speaker is Camilo from Baby B. You might have seen his very fascinating kit back there. So Camilo's going to be talking to us about his technology around neonatal care. So, right, straight over to you, Camilo.
Hey, thank you. First question. Can you hear me like that better? Or with a microphone? Microphone? All right, good. So yeah, thank you for the introduction. My name, as you said, is Camilo. I'm originally from Chile. I'm the CEO of Baby Medical, a medical device company that helps people to become families. I'm going to explain a little bit more about that later, but just wanted to kind of a little bit commit. I'm a product designer, so my background is not as highly technical probably as you, and so what I'm going to explain from the conceptual side, how we address healthcare and the inclusion of wearables in healthcare, and now how we are transiting into using IoT technologies into to improve the healthcare of premature babies. So Baby B is a company that is actually based in Stuttgart, Germany. We have our office here, and also we have some things going on in Chile and Latin America, studies and such. We're going to explain you first of all what is the problem. I don't know if any of you is familiar with the problem of premature babies. So just to quickly explain it, is each year there is around 50 million babies around the world that are born too soon, and they had to spend, on average, their first 3 weeks inside of a box, which is called incubator machine, right? So this is 10% of all babies in the world. So this very good chance, and maybe one of you here, a couple of you, probably 3, were premature babies, right? So these babies that will spend this amount of time, this first 500 hours inside of the incubator machine, they don't have any contact with the mom. And that is by design, right? The incubator machine is a machine that helps them to actually finish the incubation process. Now, it has been proven that the contact, skin-to-skin contact, the direct contact with the mother, between these babies and their mothers, help the baby to overcome the birth trauma, so get better sooner, in up to 50%. But this is massive. The problem is, the most critical premature babies, they cannot have access to this, let's call it natural therapy, which is being in contact with the mom. In a technique that nowadays is called kangaroo mother care, because they take the baby out of the incubator machine and they put it in the mom's chest like it would be in a kangaroo situation, right? So when we identified this problem, and because we were involved in another project also with neonatologists, and we see how babies were so isolated in these machines, and the mothers were outside the neonatal ward waiting for having visitor time with their babies. We set to figure out how we can bring the benefit of kangaroo mother care and the benefit of being held by the mom to the most critical premature babies, which are the very low weight babies, which are babies that are from 2,000 grams down to, well, the lightest that we have was 800 grams in the study. So how we can bring the benefit of the mom to all these babies that cannot be taken out of the incubator machine. So this was the initial solution. It was the first prototype that we used to pitch to a hospital in Germany. So it's just a very simple idea. We have some kind of token collar on the mom, and then we take the information from the breathing motion of the mother and the heartbeat, and we replicate it in the mattress on which the baby is lying. So when we presented this to the group of the neonatology in Stuttgart, it was a very interesting experience, because this was actually my master's thesis, and I was with my supervisor here, and I was just presenting to a group of around 11 doctors, nurses, and physiotherapists an idea of what to do with their most critical patients. And in the meantime, I was just blowing into this little straw attached to a balloon in a pencil case with a Playmobil on top. I thought they would kick me out in the moment that they saw this coming, but they took it, they passed it around the table. Took us like 15 minutes, very stressing 15 minutes. And when it reached to the inside of the table, which was the chief doctor of the neonatology, he just uttered one word. It was just like, yeah. That yeah meant that we will have to bring him in a couple of weeks, a new prototype, and start working on this project further on. So around 7 years has been from that moment, and now we have a medical device that is CE certified as a medical device class 1, and it's already in more than 10 hospitals in Germany, in Italy, in Austria, now in Saudi Arabia, and one here in London also. So it has been a quite interesting journey that we have going through, considering that the company, now that we are growing very fast, we grow almost 50% in the last month, because we hired 2 people. So now we are 5, so it was a little bit less than 50%. But yeah, that was like in a very short, short version, the story of the company. So let me explain a little bit how this works. There is 3 components in the system. We call it the baby V system, and the concept is very simple. We sense heartbeat and breathing motion from the mother chest with a device that we call the turtle, which was designed to give the mother the sensation of holding a baby without giving her a doll, which would be creepy, of course. Yeah, and that turtle has a lot of sensor. We check the heartbeat and the breathing motion of the mom. We send it wirelessly to a control module, as we call it, which is what you can see over there. Just take the information coming from the turtle, process it, and use it to control the mattress on which the baby is lying inside of the incubator machine, inflating it and deflating it at the same rate that the mother breathes. So when the mother breathes in, the mattress will inflate, and when the mother breathes out, the mattress will deflate. And that's kind of the information that the baby will find familiar and will help him to calm down. So a little bit of context: when the baby is a premature baby, all the information that still happens in his brain is pretty much the sounds and the motions of the mom in the mom wombs. Being breathing, one of the most prevalent one, heartbeat and blood circulation. So with this, we can simulate heartbeat and breathing motion for the baby outside the womb. This will help him to calm down. When the baby calms down, cortisol levels go down, oxytocin goes up, and this improves or helps the whole system to actually mature faster. And when the baby is maturing faster, which means that all the organs are working better, they gain weight faster. And when they gain weight faster, they actually can get out of the incubator machine sooner, because there is a threshold, usually 2,000 or 2,500 grams, on which the doctor, depending of course in the condition, can say, okay, the baby is ready for the next stage of care. And we're trying somehow to trick the baby to feel that it's still with the mom, and that will help the baby to use his own body to help himself. Which is something that I will discuss a little bit later, which is using the information from one person to control a machine that helps another person. So I wanted to jump a little bit now in the spaces on which we think that can be improved, the healthcare spaces that can be improved in our specific neonatal intensive care units by the use of this kind of concept and this kind of technologies. So the ideal situation for a baby is of course being with a mom, right? And not only because it's an emotional thing to be together, which is a very important thing, but also because of a physiological thing. When the baby, like a term baby, like a healthy baby, and the moment they get born, they just they place in the mother chest, they feel the mom, and they start to reconnect with the outside world. For putting it some way, they start exploring the mother's body, and that gives them clues of who they are, how the system should work, in terms of very specific things. Things that happen, for example, when you put a baby on the mother chest, heartbeat and breathing usually synchronize. And that's not a small thing, because that somehow feeling the motion of a breathing tells the brain of the baby how his own body should work. Right? So you're giving information to that body to actually understand itself and somehow begin life and start working properly. In premature babies, that connection is lost and is replaced by that machine, which is the incubator machine. Have you ever, do you remember the intro from The Simpsons? You know, when Homero is working there in a glove box, you know, using radioactive material? Well, incubator machine is the same concept, that instead of having radioactive materials, you have maybe radioactive babies. Well, the thing is, the concept behind the idea of the incubator is a device to treat critical items. right? It's not something thought to treat people. The idea of an incubator is for dangerous items, not for people. And if you add all the information that you need to get from the baby to treat the baby, so you have ventilator which breathes air inside of the baby, feeding tube, oxygen saturation monitor, which is something that measures the oxygen levels on the baby, and that kind of is a telling sign of the whole system of the baby. And we're using that, I will explain later also. Temperature monitor. So there's many things that are connected to the baby in this kind of situation. But it's not the mother, right? So what we have is the mother is isolated from the process, right? It's removed from the process of carrying the baby and replaced by a machine, which is the incubator. The main function of the machine is just keeping the temperature stable and the humidity. That's what the most basic incubator does, and that's what the baby needs somehow to finish the incubation process. Now, from the baby, we get vital signs. That's information that we get. So we deliver temperature, humidity to the baby, and we get vital signs in several different ways, several different data sets from the baby. What we do with the baby bee, we keep the machine as it is. We don't intervene it, but we work a way around to involve the mother into the process and bring the information that is missing from that whole environment, which is in the most basic form, of course, heartbeat, breathing, and voice from the mom into the babies. So somehow we take the mother out of the installation state and also kind of reconnected the baby and open a window for the baby to start feeling improving the environment of the baby with what should be, which is the mom. Now, there is another thing that we are working at right now, which is because of how we design the system, we can reproduce sound in the mattress without the needs of electronics within the mattress. So there is a very relevant point there, because the incubator machine is a oxygen saturated environment. So if you cannot put electronics by regulation. Even they do it, but the nurses or the doctors and do it, but you cannot put electronics, because if they spark, you can create a fire, which is, let's say, suboptimal in this kind of situation. So what we do is use the ability to reproduce sound through the mattress to find new ways to involve the mother into the process. So now what we can do is basically use an Apple Watch to record voice messages or heartbeats and send that from wherever you are into the baby system, and your baby will feel it, and we have that information from you whenever you send it, right? So a little bit in terms of how it takes a village to raise a baby, that's what they say. So, and it's not only because you need a lot of people, but also because you need a lot of involvement. And how we create involvement in this area, we first of all give the power to the mom. The mom signs out in the app, and she invites whoever she wants to have contact with the baby. So she can invite the father or not, grandparents, siblings, whoever. And then you have two other environments: moments, in which is kind of a ledger of heartbeat that you send with your watch, or voice messages that you send either with your phone or with the watch also. And also you have milestone, which is kind of a journal of the baby, in which you can share with all the family group, the most important moments of that baby. If the baby has set up the incubator machine, if the baby go back home, if the baby start lactating, or such and such things that are creating some kind of a stream of little capsules of times and information of the baby for the family. Now, that's also very important, because the mom is the center along with the baby, but with this kind of technologies, we can also involve the whole family into the process. So in the cases, for example, in the hospitals that we have now, the system working, is common policy of the hospitals to accept the mom and sometimes the father also 24 hours, but grandparents are not, for example, or uncles or friends. So that's all the people that give support to the mom and to the father are not involved in the process. So the mother will be there 24 hours alone with the baby, which is a very stressful situation. So this allows us to bring the support on not only for the baby, but for the other main character, which is the mom, through the family. And this is the current state of things, how we are working now. And I wanted to jump a little bit also in the things that we are developing in the future. As a new space that we are figuring out, which is very interesting in order to create new interfaces for the baby. There is one specific sensor that we showed before, which is the pulse oximeter, in which you measure the oxygen levels in the blood of the baby. Now, if you should ask you an NDA for this, but if you take the pulse oximeter can identify bradycardic events, which is when the heartbeat start like beating slower, right? And this, and also can identify, give us a signal just before an apnea event happens, which is when the baby stops breathing altogether, which is one of the main issues in terms of main factors in terms of sudden infant death. So if you have that information and you have a physical actuator, because what is the treatment for apnea usually in hospital? Just nurses come when identified, move the baby, shake it a little bit, the baby kind of reacts, and then they start breathing again. Now the thing is, between the moment in which the nurses realize this apnea event happening, or bradycardia happening, and they act on the baby, it actually can take critical time. But if you have that specific alert, early alert, and you connect it directly with an actuator like our mattress, you can create that stimulation before, like an automatic stimulation that brings the baby out of the apnea or the bradycardic event, and save a lot of very, very, very critical time. So using all the information that we have now available, because that information is available, and you have ways to take it out of the monitoring from the sensors, and you start connecting it with this other different device, you can actually create a circular system that helps the baby helps the system to take care of the baby in a more efficient way. So that's pretty much all what I want to share. We like to think about when at the beginning I said, like, we like to think that what we do is just more than helping babies to get better, because when you realize that the effect that happens in those early days of being connected with a mom is not only about getting healthier, it's just the beginning of a very important relationship, which is the baby with the mom and the baby with the father also. But that's the whole thing that is gonna affect the whole life of the baby. The idea of being somebody's daughter, somebody's son, and the mom, not just to be a woman that has a baby, but being a mom, which is something very relevant and only happens, as they tell us, when you hold your baby, when you're able to care for your baby. This picture over here is very meaningful to me because she's a very good friend of mine, and that baby was 28. He's a 28 weeker. It was very, very early. She's Olivia, and when I had the chance to actually bring the device to her in Chile to care for Olivia. She told me whenever she started using Baby B, and it was the first thing that she could be involved in the process, she could feel that she was the mama of Olivia for the first time. And that's, I think, is a very important switch to make. And these kind of technologies that allow us to use information for one person to influence another can have in the future of healthcare. So, thank you. There is a, well, no, it won't be good, because in these kind of situations, if you're holding a baby, a very small baby, you're not going to be running around the room, or you're not going to be driving on a traffic jam, you're not going to be on the gym, you're going to be with your baby, you will be sitting still and having that moment. So for that specific purpose, we take two measurements. One, of course, is we capped the information that we translate, that we give to the baby. So if the mother gets overexcited, that information will be capped and it's only going to stay in the saved area in terms of the sound of the heartbeat and the breathing motion. And the other thing, which is kind of for more, it's a little bit more subtle, is the design of the turtle. So when we design a turtle, it was not because we like turtles, right? It makes no sense actually, but because we study how these the mothers interact with their babies in a haptical way, touching the babies in kangaroo care position, in the kangaroo care technique. So, and then we try to figure out, okay, this is the surface that the mother kind of touch, feel, caress, and design something that weight in the same way that allows the mother to have the same kind of haptic experience of the baby. So in the process, it was, at the beginning was a little frog, looking like a little frog. At the end, it was after it was like a little pea or something like that. It ended up being kind of a turtle, and just because that was the most subtle way to present the same surfaces that the mother needs. Now, you can have the same sensors, attached to a black box in your belt, and it's going to be easier, it's going to be cheaper, and it's going to be more, easier to deliver. But by having this device that intervenes the mom, so the mom, she cannot just tie it around her, she has to sit down, it has to have a position, she has to hold it, she has to be in that moment. You force the mother to actually be in that moment, and when she's in that moment, their kind of maternal state of mind kick off, and then her heartbeat, her breathing will be modulated, and that's information that you need to translate to the baby, not the mother sitting on a traffic jam or working out in the gym. Yep. Did answer? Yeah. No, and that's by design. We like to say that we are baby-centric company, so we wanted to help, most importantly, the baby. But it's because of how you deliver that information is very critical to the mom. How you deliver the information of the state of the baby to mom. So, to give an example, we can translate now, bring the heartbeat of the mom to the baby, and that's not a problem. But if you bring the heartbeat from the baby, to the mom, you will have this problem. The heartbeat, what happened with apnea of bradycardia? Imagine you're feeling the heartbeat of your baby continuously, and suddenly stops. And you don't know what happened. You kill the mom in that moment, right? It's like, so then you have to start thinking about, okay, so we cannot give like one-to-one description of the heartbeat of the baby to the mom, because you can have these issues. And now, then how you do it, how you bring the information to the mom, how you filter the data for the mom. And I think the most effective way to deliver now is nowadays in place, which is doctors talking to the moms. And we don't want to jump into anybody's toes, but also because it's a very critical issue just to deliver, to overflow somebody with critical information of a patient. So you don't want to have the mom to know every beat of the baby. You don't want the mom to, because she doesn't need it. And the focus is helping the baby in this moment. Well, you can. We did a crossover study, pilot study, and we figure out like the weight factor is very relevant on these babies. If they gain weight faster, means that they're actually getting better faster. And we realized when we did the study, we figured out that babies using our device increased from 15 to 65% the speed of the gain weight. So babies feeling their moms actually get better sooner. And it was the same baby. I mean, it was the same baby compared with using and not using baby. It was not comparing baby, also one baby. Yeah. I think you have. Yeah. No. No. The one thing is like everything goes through the mom. Right now. So if you are the uncle and we're uncle sending weird messages, the mom will hear before send it to the baby. Yeah. Sure. Thank you.
One, two, 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 one, two.
Falk Lyle. Excellent. Who is part of IoT Scotland, and they're implementing a national business grade LoRaWAN network. So really super excited to see the first implications for business and for us as the community. So without any further ado, over to you, Falk.
That's great. Thank you. This sounds trivial compared to what we just heard. Well, I hope it will be interesting for you anyway. So just to give an idea as to what Boston Networks is doing and how it all came about in the first instance. I suspect that many of you will know Census as one of the innovation centres run in Scotland. It's based in Glasgow, and Census a couple of years ago approached actually Boston Networks and another organisation to look at the idea and develop the idea of having a nationwide LoRaWAN deployment across Scotland. And together with Census, there were approaches made to the Scottish Government, to Scottish Enterprise, and also Highland and Island Enterprise Council. And together, the idea was born to effectively build an infrastructure like that. And Boston Networks at the time, and this was then at a time after I had joined the business, we applied for some grant funding, which was approved, and as part of that, it gives us the opportunity as a company to actually build a nationwide LoRa network. There's quite a significant investment for Boston Networks also as a company. It's 50% or just over 50% in this scheme. So there's both significant funding from us and also significant grant funding from the government. The idea is to roll out some 500 LoRaWAN gateways. Don't know if you know what that means in terms of potential capability. That will become clearer as I go through some of the slides. We have some gateways up in Inverness. We're rolling out in Argyll and Butte in Glasgow at the moment, and I'll explain in a minute what we're doing to effectively get to a place where we roll out across Scotland as a whole geography. If you don't know how IoT in a LoRaWAN context works, here's a very brief explanation as to what happens. Is you have end nodes or sensors, typically battery operated devices that have a radio chip in them and an antenna. They then communicate wirelessly with gateways that are deployed by us, in this instance, across a large geographic area. We backhaul the data from those gateways to a network server. The network server takes the information and routes the information effectively, depending on who the sensor owner is, then to their respective application servers. And it can do that at scale with hundreds of thousands or millions of sensors perhaps on the left, and also a large number of application servers on the right. The scope of the IoT Scotland infrastructure that we're building is that bit in the middle, so from the gateways, including the backhaul and the network server. And what it does is it makes the innovation, perhaps not the foundational stuff, as in maybe building sensors or so, but certainly the proof of concept, the real life deployment, easier, more cost effective, and also quicker to achieve. And what that means is that organizations will be able to actually participate in this process, either through pilot studies or early deployments, or at some point also scale deployments. I take it for most of you, this poorly executed German gag is sorry, Germans don't have a sense of humor, and I really agonized over this to try and get something. But basically, LoRa is a low power technology. It's wireless, it enables long range communication, and it has low bit rate. So what that means is that it's not the next super fast broadband. It does not provide super fast broadband connectivity to rural areas in Scotland or so. That's not what it's there for. It can convey fairly small bits of information, or small messages, if you like, but it does so with very little power. And that is what really makes LoRa as a technology really interesting, in that it allows sensors that are battery operated in an environment where they don't have any infrastructure that they can latch onto in some shape or form. It can make them, or allow them to operate for several years without having to change batteries. And that is really powerful, and also being able to deploy those kinds of sensors in areas where you don't need to do anything infrastructure-wise. So it's very simple in an area where there's coverage to either deploy them internally or externally at a very rapid rate, and then have those sensors connected and communicate across the network with central application servers. Why did we choose LoRa as a technology? In blue, you see the kinds of things on the short distance and up to large speeds map there. Basically, those things that happen either within buildings or maybe just outside buildings. In that salmony color, you have the network operator type services. I've put Narrowband IoT in there as a technology that kind of sits in a similar space to LoRaWAN as a technology. You may also be familiar with or have heard of Sigfox as a technology, which occupies a fairly similar space. It has some technical differences, which also make us prefer LoRa. It is very cost effective when it comes to actually buying sensors or developing sensors and then connecting them. And also, something that was really important to us as an organization is there's a LoRa Alliance. It's a global group of participants in this space. There's some 500 organizations that either make sensors, that provide services, or that operate networks that are part of this alliance, if you like. And what that means is that there is a continuous flow of new sensors that come out and are made available. Just this morning I was speaking to somebody and had a look at a real vibration sensor, which I thought was rather interesting. And it's a LoRa-based device that you can stick onto the side of a railway track and then get information that's vital or can be vital for the rail industry. But that's a very specialist sensor for a very specialist environment. But this is the reason why we chose LoRa as an IoT infrastructure and as the technology of choice. When we set out what to do and how to build this network infrastructure, we decided that we wanted to build effectively a carrier grade network. Why is that important? Because if you want to deploy any services on that, that you run not for your own consumption, but perhaps as a service provider, it needs to be reliable. It needs to be predictable. It needs to be something that if one of our customers provides a service to their customers, that they'll be able to contract for services and actually be paid for services as well. So what we've done and what we're doing pretty much on a daily basis at the moment is we do quite intensive radio planning. We invested in some software. It costs about the same as a car, and that allows you to actually model and predict where coverage would be possible based on various locations that you have. And you'll see on the next slide, some output from that. This is actually output from this tool also. Don't know if any of you recognize the coastline or anything like that. That's Oban, if that helps. But basically in Oban what we did is we looked at 3 potential locations for gateways and in order to predict coverage. And you see the heat map there basically showing the signal strength, from blue being at the lower end and then going up to the almost white hot on the other. Now what's important, and for those of you who play in the technology space, you'll see at the bottom the scale that we're planning down to minus 100 dBm. What does that mean to you? Yeah, you have plenty of space to go beyond that also, okay? That's important because really for us what we're trying to do is we would rather under-promise and over-deliver instead of the other way around, and also because the tools don't necessarily take buildings fully into consideration, that we have some margin to actually provide indoor coverage also. From a gateway density point of view, we're looking to claim coverage, if you like, in those areas where at least 2 gateways provide connectivity for a sensor. Sensors are not aware as to what gateways or how many gateways pick up their signals, but we're planning in such a way that we have sufficient gateway density to provide that level of cover. We have a network server that is set up in a high availability configuration to again provide high levels of service. And from a security point of view, the network itself and the technology provides a number of layers of security built into that. LoRaWAN as a protocol gives you some as far as the over the air and also into the network server communication are concerned, but we have other layers of security that sit on top of that, covering connections between the gateways and the network server, and also between the network server and the application servers. We're building and we're planning to roll out according to a rollout plan on the one hand, but we also deploy on demand. So I'll give you one example. For our fastest deployment for a site, we had one request to provide coverage in a particular area. We received that request on a Tuesday afternoon. We got the legal documentation signed as far as the access to the site was concerned. On that same day, later on in the afternoon, we installed and commissioned the gateway on the Friday. So within 72 hours, effectively, we went from no coverage to coverage in that particular area. And that's something that we are doing and that we're willing to do. I'll say a little bit more about this later on, but if there are any amongst you that may wish to become involved in this process, we'd be more than happy to talk to you about this also. One thing that we're also doing, and touching on the low power element, this also applies to the gateways in a way, that they don't consume much power. We're in the process of looking at an off-grid solution, where we have the technical solution. It's likely to go onto a top of a hill in the Highlands somewhere where we get mobile coverage as far as the backhaul is concerned, but where there is no power or anything like that. And it's been designed in such a way that it can literally be hand lifted up to the top of the hill and installed there. And that's part of the research, if you like, that we're doing, and also the innovation that comes with it. To give you an example, and I'm really sorry to those of you who are from Edinburgh, but I'm using Glasgow as the example here, but this is where we've done this. In Glasgow, we went through a process where we spoke to the local authority, and they bought into the principle of what we were trying to achieve. They offered us 95 buildings that we might want to deploy gateways on. We put that information into the radio planning tool. The planning tool then basically went through the optimization process and basically determined that 22 gateways would be required to provide coverage across Glasgow. Glasgow's the bit in the white outline there. As you can see on the left, it's really only on the margins, so not in Glasgow itself, except for a tiny little bit in one corner, where only one gateway actually provides coverage, again at minus 100 dBm, so at a high signal level. Green is 2 gateways or more, yellow is 3 or more, and red is 4 or more gateways. Why is that important? Again, for resilience purposes on the one hand, but also because geolocation capability kicks in when you have 3 or 4 gateways, 4 ideally or more. And that means that a sensor that doesn't need to have a GPS capability on it, just any sensor really, even one that just reports temperature or so, can be located with this capability. And we have the capability in the network. We haven't switched it on as yet, or we haven't deployed it as yet, but we're there, and we're happy to look at any use case where that might actually be of relevance and kick in. So again, with that, you can see that with a relatively small number of gateways across Glasgow in this instance, or Greater Glasgow, we're able to provide significant and deep cover across the city. And that's the kind of cover that we're looking to provide across Edinburgh, the other cities in Scotland, and also major towns, and then in other areas on demand. So for anyone interested in hosting a gateway, it's small, it's about the size of a shoebox. It uses very little energy, uses about less than a quarter kilowatt hour per day, so it's pennies to run it. We use mobile backhaul. What that means is we don't need to go and install a fiber to the home or whatever service, to that particular location. Everything happens on the roof. We just need a power connection. We connect the power, and we do the metal work and so on to actually get it up onto the site. Ideally, you would want one that's 15 meters or higher to give you good coverage within the area. And we then install and maintain that. We don't need out-of-hours access to the site. It's important, again, because otherwise you're limited to the number of sites or the types of sites you would be able to connect to, and that's it. And for any people worried about radiation in that respect, I always say you could hug one of those antennas all day and you'd be fine, because it's just so little by way of output that it actually has. Just to give an idea, and I'm very open as far as the pricing is concerned, to give you an indication as to what it is. Headline price, if somebody commits to a 3-year contract, is £1 per sensor per month, and it's in those packs, if you like. And as you can see, the pricing is extremely regressive in the sense that by the time you get to 1,000 sensors or more, you're at the 40 pence per sensor per month level. And that means that the cost of connectivity should not be an inhibiting factor for anybody, actually using this technology going forward. That means we're building this for scale, and we're looking, for a large number of devices that are actually deployed across this. How do we work with companies that actually want to connect? And it's either companies or maybe other types of organizations. Typically what we would do is we would sign an NDA, we'll set up a test account on our platform, an organization would send us a device, we'll provision that device on the network, and then we'll let the organization that wants to connect effectively work with the application server settings until they're happy that this actually works. We've done this about half a dozen times now with different organizations. The quickest one's done that within less than a day to actually get it up and running and working. And then after this is done, basically, and the integration test has been complete, an organization will be able to self-serve, will be able to self-provision devices on the network, will be able to self-provision the application server connections. If they want more than one, that's fine too, and then basically get the services on the back end of it. Where are we going with this? So firstly, obviously, it's the geographic rollout that is important for us, but we're also looking at offering multicast services. That's something that's already, again, part of the capability of the service itself that we have, but we haven't launched it as an official feature. I talked about the geolocation piece already. That will be a launched feature at some point, but we want to do some real-life testing ourselves. We know that the same technology stack that we're using here already runs geolocation, so the technology is not in question here. It is just actually the application of the technology. MQTT as one of the protocols will become available shortly. At the moment, again, for those of you who are into these kinds of things, we're using RESTful API and WebSocket as connectors effectively, and MQTT is just around the corner. And one thing that I'm very keen to look at also is roaming, and we've had some initial discussions already with a local university not far from here, about actually looking at establishing roaming capability. And for us, in the next software release on our network server, we'll be able to test it, and we'll be keen to look at that and also at concepts that go beyond peer-to-peer roaming, where we start looking at maybe some kind of roaming exchange or so in that sense also. So that's it. I mean, this whole process, as far as the funding is concerned, to where we are now, is taking about 6 months. as such, we're now in a position where we have a launched service, we have our first customer that's in the process of being provisioned, and we are delighted about that, and we're clearly excited to see some scale developing over time on the back of this also. Do you have any questions? Yeah. Yes. No, not really. So far, that hasn't been a constraint for us, even in some of the rural areas, like Campbelltown, for instance, and so on, where we literally cannot get mobile signal coverage. Our heritage as a company is in wireless networking, and we can use other wireless technologies or fixed line technologies also. So if on the rare occasion we need an ADSL connection, for instance, even a slow speed connection, then that would be okay. But we can also use licensed or unlicensed microwave, even TV white space connectivity, to get to locations where for some reason we can't get a mobile signal. Okay. Yeah. So there are some protocol limitations in terms of duty cycle and packet sizes as such. Now, for temperature, you can probably get a temperature sensor, send its information in a single byte payload, if that's all that you will get. And the frequency, we would work with our customers typically, to ensure that temperature, for instance, is not measured maybe every 10 seconds or something like that, but perhaps more, like every 5 minutes, every 10 minutes, every half hour, whatever the application actually requires. It's not in anybody's interest to get more information sent than what is actually practical and reasonable. Yeah, sorry. Thanks. Yeah. Okay. So timescales, we're looking to roll out those 500 gateways over the next 2 years. But there is no difficulty or no reason where there's a requirement in a particular area that we will roll out in that area first potentially before going somewhere else. What I mean by that is the network doesn't need to be grown contiguously, like a fiber network where you need to keep digging as such to get somewhere. We already have gateways deployed in areas which typically you wouldn't connect simply because we can and because there was a demand. Sorry, the second question? Okay. So we see great interest and potential scale also in terms of housing and housing stock monitoring, for instance, compliance as far as temperature is concerned in a variety of different settings in industry, health and social care, those are the main ones where we can see things right now. And it's not just big companies, but it's service providers into those industries. That would typically be our customers. But there's absolutely no reason why an organization that wants to test fill levels on oil tanks or something like that, couldn't come to us directly and just say, here's a very specific requirement that I have for, a small number of devices initially, and then just get the service. Okay, sorry. So no, we're channel planning as part of this. We also have we have the capability to effectively run a frequency scan on the gateways when they're out in the field, so that we can see if there is any interference. So different frequencies at different locations, or different frequencies, you know, across the same city, effectively, you know, for different gateways. Yeah. Okay. So I think you're right, although if you ask Sigfox, they would have a different answer. I was at Mobile World Congress, and out of dozens of conversations I had, Sigfox came up once. Okay, and that to me just basically paints the picture. You know, the packet size limitation that is there, both upstream and downstream, you know, is a real limitation and an issue. The fact that, you know, effectively there's one service provider, that's a bit of an issue. The fact that there is no development community in the same way that you have the LoRa lines, that's another limiting factor. And I think over time, you know, between those two technologies, even though Sigfox has significant coverage and also, you know, rollout in other geographies as such, I'm not worried about it from a competition point of view. Again, I would argue that certainly in the foreseeable future there's no real competition in that respect. From a power consumption point of view, for battery operated devices, because NB-IoT uses an order of magnitude more electricity than LoRaWAN does, I don't see it as a direct competition in that space, but we know that Vodafone is the main proponent in that respect. I'm sure with its formidable size and marketing machine and so on, there will be NB-IoT rollouts, but I would suspect that would be in those areas where there's Vodafone coverage already. Yeah, so it's between the sensor and the gateway, and long range depends very much on the terrain. So within the city centre, large built-up areas, streets, winding streets, you know, old buildings in Edinburgh, you know, hills and stuff like that. You know, you'll be limited in that respect. But we've seen LoRa sensors in that kind of an environment communicate over 2 kilometers comfortably, and you know, where there's little or no obstruction as such, you'll get to 15 kilometers and beyond. In fact, there seems to be, if you look online, competitions about, you know, how far you can get, you know, connecting a sensor to a particular gateway, and some have managed to get, and this sounds crazy, hundreds of kilometers, as in a couple of hundred kilometers worth of connectivity. But that's then under ideal, or should I even say exceptional circumstances. Okay. Indoor coverage. So indoor coverage depends, again, very much on the building fabric. And if you're in a building and underground, for instance, and it's a large building, you may not get external coverage to that particular site. But we can provide indoor as an infill coverage, if you like, by deploying indoor gateways that become part of the same network and are served by the same network server effectively. So if, for instance, there's an area where today there's marginal coverage externally or no coverage externally, we could deploy an internal gateway, and then when the external network coverage catches up, then you can remove the indoor gateway and move it somewhere else. Yep. Possibly, yeah. It would be, yeah. Is that the gauntlet then basically that you're throwing down? Yeah. Okay. Well, that's a deal. That's a deal. Okay. Any other questions? No. All right. Yeah.
I think what we'll do then is also just have questions for Camillo as well, if you want to grab some notes. So the question from the live stream, and just forgive my lack of technical chops here, but it says, activity experts, this is from Gokhan Icon, asks, activity experts told the web conference that instead of 20 LoRaWAN gateway towers, 120,000 micro gateways with 30 to 200 MT distance should be installed to provide even better battery consumption. Do you have any comments or response? Also happy to.
Yeah, I would
Thoughts,
ask.
comments, or observations?
I would ask who pays for the 120,000 micro gateways, and who powers them. Yeah. So, I mean, it's really interesting. Excuse me. It's really interesting because when it comes to Wi-Fi, for instance, you may remember over the last few years where Wi-Fi coverage, people talked about all the public Wi-Fi providers and so on, and then all of a sudden BT acquired phone and turned every BT home hub into a phone gateway, and then claimed to have 1 million plus Wi-Fi hotspots across the country. Don't know if you remember that, but in a way, this almost sounds a little bit like that, but I don't know. All right, okay. I didn't realize we were in Turkey. This is almost Eurovision song contest style then. Thank you. Yeah, amazing.
Yes. It is. So, yeah, as you said, we are not part of a bigger company. We're just a really very small company. I don't know if there is any other medtech company that is as small as we are. So what we did, because somehow we don't have either the funding or the capacity to go through all certifications as a company ourselves. So everything that it has to do with how we back up the liabilities of a medical device product, we find ways to rely on partners for that kind of issue. So, for example, for the product itself, you have to go through the certifications, and in terms of 6001 and all these kind of things. There is always the question that if the usual thinking is you go to the closest port or to your neighbor to figure out if they can do whatever you want to do. In terms of, for example, certification, you will find local partners, but that nowadays that is not the most efficient way to do things. So, just to put an example, the company is based in Germany. In Germany, in the world, there is kind of two main things to make companies that are certified: TÜV and SGS. The difference, we actually went for SGS, but the difference between the prices of SGS in Germany and in China would actually give you the same quality nowadays. They give you the same quality, the same reliability, but they don't give you the same price. So that's is a way to make the whole thing efficient. And yeah, it took us still over a year to certify the product. and in that process we also had to redo the whole sourcing and the production chain of the device. So all the suppliers and manufacturers that we work with, they are all certified 13334. 13. This ISO numbers, they always confuse me. the medical ISO certification, the 9001, everything. So everything is like we have a very well-defined traceability matrix of how the parts and components come about and how they deliver to the clients in the most clear way. But we don't rely on doing everything ourselves. That answers. Yeah. We do it through filtering the signal from the different accelerometers and gyroscope that we have in the turtle.
So, Falk, so I've got a question for both of you. So, Falk, firstly, I think the vision for the LoRaWAN network is just phenomenal. I think the innovation it's going to enable is going to be massive. As the number of devices starts to scale up, the sort of, let's call it the health check capability of the devices to see if the devices are still alive, and consolidation of the sensor data. Is that something you're going to be providing as part of your network, or is that on the partners or innovation companies or businesses to provide that information themselves? Where do you see that capability sitting?
So most of the sensors that we have currently deployed on the network will report on their battery life, or the state of their battery. So with that, we've come up against some really interesting surprises. One sensor where the manufacturer claimed a 2-year battery life is dead after 3 months, whereas another one, the battery is still showing 100%, after having been on and live for that same period of time. So, because again in my diagram, if you remember, the sensor is the customer or the service provider's responsibility, and the same with the application service provider, because we are just conveying the data there. We have no direct view on why a sensor may or may not be communicating anymore, or what the information is that is being communicated. Because it's encrypted end to end, we'll not actually see the information that comes from the sensor. What we do see, and what we do recognize on the network, is that if messages are sent from a sensor, we can see the signal strength and the noise levels at that particular time. And because sensors don't need to be physically located in one place, it's quite possible that somebody moves the sensor simply out of the range of a gateway. So for all those reasons, we are the postal service, if you like, rather than the actual conveyor or the provider or the producer of data.
So you deliver the post, you don't read it. All right, excellent. Camilo, a question for you. Seeing as we've got both of you guys here, I mean, the data that you're connecting is extremely compelling. But in terms of, within the context of the LoRaWAN network, does your data sit sort of in a closed loop? Is it, or is there the ability to be able to publish that data or make it available? I'm seeing dashboards of moms everywhere and the health of their babies at a sort of national level. Is that something that you foresee? Or is at the moment, is it very much that closed sort of local network between the baby and the mom? And where do you see that developing?
At the moment, it's just a closed network. And that's, we are looking for ways to kind of use that information in a broader way. Not only one, for understand better the process, but also to be able to create new services and jump from the hardware to the services either from the hospital, for the hospital themselves, or for the end user, which is the family. And in the stage that we are now, in which we entered the market not very long ago, and in the process that we have been doing that, there has been very stringent changes into the how you use the data of the patient. And so what we're dealing, when you have a mom or you're having information from the baby, counts as a patient data, right? So it's very, and that's very sensitive issue. And if we go into somehow start using that information with the current stage and setup that we have right now, it will involve massive redesign and massive investment in terms of you know, making the whole system very secure for the usage of the data. And of course, paying licensings, and also it has another kind of commercial issue related to how you use that. And you know, I mean, it's just like make the whole thing more complex. So right now, for example, the information that when you use the turtle, when the mother uses the turtle and send information on real time to the baby, but when she's using the turtle, the device is recording a piece of that information. So when the mother is not available anymore, you can play it in a loop for the baby. So the baby will have something from the mother 24/7. Now that information is stored until you unplug the device. If you unplug it, the information is lost. You have to create a new recording. It's just like a safety measure, and you cannot extract it in any way. So it's just locked inside of the system, so nobody can actually make use of that information.
Hi.
My question was, other patents done?
Yes, we have patents granted in Germany, Europe, and the US. Yeah, and it's a PLT. I think it's the name of the patent that you can that we have in the US that we can actually just start validating in different countries around the world once we go into that market.
Got a couple of questions. How secure is Baby B against tampering? There's always going to be some joker who wants to interfere in some way. Second question is, if a premature baby's skin is very delicate, is there any danger of abrasion from continual movement in just one position?
Yes, the device is very, very secure in terms of the worst thing that can happen is that the system stop working, and in that case, the materials on which the mattress is made is even so much better than the current mattress that the babies are. So it's still going to be improvement from the current status of the baby, and it's designed to be kind of. So you don't have any, for example, you don't have any access in terms of it's not connected to any kind of network other than the radio frequency that we use for communication. We did only with one turtle with one control module, so it's very difficult to tamper in that way. So even if the device goes completely crazy, which we'll never do, the thing that is going to happen is just like we're going to have a better mattress than the baby will have so far. So that's in terms of safety. The second question was, sorry again, oh yeah. Yeah, so there's two things there. One is the skin and one is the brain pressure, right? Because in terms of skin, we have the material is a material that was developed from Bayer, and it was developed for anti-bed sores or the QB2s mattresses. So in terms of that's why the material, what I was saying, that the material is actually better in terms of what is right now. We could just, because you have a three-dimensional weight relief in the mattress that we have, so it's a lot better for not producing bed sores on the baby. So that's in that regard is better than any kind of mattresses that the hospitals have right now. Now with the motion, there is specific issues that happen with the most premature babies, which is the evolution or the changes in the intracranial pressure, and that can be affected by movement. That condition is when they have like people brain pressure is very easy to detect, and in those cases the doctor decide not to use the device. So, and in any other, and that's a very minor case in terms on the premature babies, and otherwise it's just always better to have the baby stimulated through motion. Even those babies who are the most critical ones, we have issues with the intracranial pressure, are moved several times a day, change the position, so they can sleep better, they can digest better, they can actually not create bed sores and such and such. So very little, and it's actually one of the most accepted techniques in terms of positioning the baby in the incubator machine on any kind of bed is they call it they restrict the motion of the baby. So why? Because in the womb, the babies actually push the walls of the womb in terms of fill the space, and that create better muscle tonicity, muscle tone, right? So for example, what they do now, they create containment around the baby, so the baby, for example, can push with the little legs or push with the arms, and that helps them to create this muscle tone and also to start using the body in a better way. So the babies will move, but that motion has to be contained. And the smaller ones, we are talking about babies under 2,000 grams, they don't move much by themselves.
A question for Boston Networks. Are you active outside of Scotland? And if not, how come Boston Networks?
Tough one.
One of the founders was in Boston, Massachusetts, was thinking about a name for the company. This is some 20 years ago, and said, Boston, I like that name, I'll have it. That's how the name came about. And operating out of Scotland, outside of Scotland, yes. We will, albeit on a slightly different financial model from what I explained here. So basically, for the rest of the UK, there would need to be some commitment to a number of devices connected in order to fund the rollout of gateways. But same technology, same processes, same procedures, same capability can be deployed there.
I must say your financial model is quite compelling. What is your strategy for bringing in partners and people to essentially send mail on your freshly built network?
So we've already started that process in that we are working with organizations that have sensors and who want to sell them. And quite often for them, the network element is an irritation or a necessary evil. And basically having that and providing that as part of this at a very compelling price makes it very simple for them to say, look, we're not bother deploying our own gateways, we'll just use yours, and then basically take services. The organizations we're speaking to, we're pushing business their way. In fact, that 72-hour gateway deployment that we talked about earlier, that individual from the organization that actually runs the mast effectively in a community environment is already speaking to one of the partners that we've done the integration testing with. So they're seeing the value coming out of this, and they're delighted then to work with us going forward. And we're actively looking for partners that just want to deploy their services across our network.
Fantastic. Guys, any last questions? Fantastic. Well, I think you guys have been absolutely phenomenal. These talks tonight have been really thought-provoking. I want to thank you guys massively on behalf of the IoT community for spending the time with us today, sharing the great work that you guys are doing. So, guys, please, a massive round of applause for our two speakers. Excellent. Cool. Also, a big round of applause to Trish and Eagle Labs for hosting us and for the pizza. Just on behalf of Simon, he sends his apologies. He's detained in the borders with the inclement weather, so he sends his regards and best wishes, and we'll see you all again soon. Guys, thanks for braving the weather, for being here, for being part of the community, and we'll see you guys next time. Thanks so much.